Alright, we're in section 5.4, and we are factoring and solving polynomial equation. The day before, we were just multiplying, adding, subtracting. So what we're basically doing is we're doing the reverse of what we did in 5.3. The only difference is you have to look for special patterns, or there's a certain way that you can solve it, and it's not always clear cut initially in how you factor these problems. So things to look for. So one of the things you need to look for is first find a common monomial factor, or just find a common factor in each of these problems. Then then you can probably look for the special patterns. Here are some of the special patterns. The difference in two squares and the perfect square trinomials are general patterns that we've seen before. You've seen them in intermediate algebra while solving for trinomials, and one of the new things we're going to find is the sum of two cubes and the difference of two cubes. So say if we had a cubed plus b cubed, this ends up equaling a plus b times the quantity a squared minus ab plus b squared. And if I had the difference of two cubes, it would be a cubed minus b cubed equals a minus b times the quantity a squared plus ab plus b squared. So keeping that in mind, let's do some examples. So I have x cubed minus 3x squared minus 54x. So the first thing I'm going to do is I'm going to factor out an x. So now I have x, and then I can rewrite this as x squared minus 3x minus 54. I can just use a common trinomial, so that gives me x, and I can go reverse FOIL, like parentheses, parentheses. I got x, I got x. This negative 54 means they're going to be different signs. The negative 3 tells me that the larger one's going to be attached to the minus, and it is 9 and 6 for this particular one. Okay, that's not so bad. Look at B. B, right away I can factor out a 2, and I can also factor out an x squared. So if I were to rewrite this inside the parentheses, it would look like 6x squared plus 23x plus 20. Now, I can try to reverse FOIL this. It was a little tricky to find which one it would be, but I do know that it's going to have a plus in here because my 20 is positive and so is my 23. So I come to the conclusion that it would work out to be 2x plus 5 and 3x plus 4. Next example, I have negative 625x to the fourth plus 40x. So I can factor out a negative 5 in this one because I like to keep my biggest degrees positive at all, if all possible. So this is negative 5x, and then in parentheses I have 125x to the third minus 8. Yeah. So now as I look at this problem, I notice that all three of these values inside the parentheses are cube roots, are makes of cubes. So I could pretend that a equals 5x, because if I were to cube it, it would give me 25x cubed, and then my b would equal 2. So that means I can use my equation from the first part of my notes, where it would be the difference of 2 cubes. So if I were to rewrite that, I'd have negative 5x. So now I'm going to have 5x minus 2. So I'm just substituting in the values that I've given for a and b. And parentheses here, this would be 25x squared plus 10x plus 4. And that would be my factored, completely factored polynomial. One of the other things that you can do when solving for or factoring for polynomials is what is called factor by grouping. So here's how you do it: is you use your own parentheses. So I'm going to go parentheses here, here, and here. So, and what you're going to do is then you're going to factor out a value inside those single parentheses to help you solve, uh, help you factor it out completely throughout the entire process of the polynomial. So if I just look at 4x cubed plus 20x squared, I can take out a 4x squared here, which then would give me x plus 5 inside this parenthesis. So then I have a minus, and I could pretend like this is a 1 here, and inside this parenthesis I can say it's x plus 5. The reason why I can say it's x plus 5 is because if I were to multiply this negative 1 and distribute it, it would mirror or be exactly like our problem initially. So we're good there. So mainly when you do groupings inside these parentheses, they should be exactly the same. So I have a match here of x plus 5 and x plus 5. So I'm just going to write that out as x plus 5. Then I can multiply it by 4x squared minus 1. One of the best ways that I can describe this process here is, let's pretend that x plus 5 equals a, let's say. So I have 4x squared times a minus 1 times a. That's basically what I'm saying. So if I were to factor this out, this has a common factor of a. So that means that I can write a, and then in parentheses, 4x squared minus 1. But what we've already established is that a is x plus 5, so I just rewrite that as x plus 5 over 4x squared minus 1. This is just if you didn't see it initially looking like this. That may help you. I'm not sure, but it does help some people. So grouping this one, for example B, if I look at the first parentheses, I can factor out an x squared, which then gives me 5x minus 2, and I can factor out a 64 out of this one, and this gives me a 5x minus 2. That's crappy x. Erase this. So I have the like terms of 5x minus 2, so I'm just going to write that out. 5x minus 2 and I multiply it by x squared minus 64. You think you might be done, but x squared minus 64 is the difference of two squares. So that can be rewritten as x plus 8 times quantity x minus 8. And now it is factored out completely. These examples, they don't tell you exactly how they want you to solve it, either by grouping or by finding common monomials or greatest common monomials or reverse FOIL. So let's just see what we can do. For this one, first off, I think I can factor out a 5x. So this leaves me with 4x to the fourth minus 25x squared plus 36. And I was trying to see if I could reverse FOIL this, and I just couldn't do it. So this is factored out completely. Great. Looking at B, I can factor out a 2y squared here, which then that gives me y to the 6 plus 4y cubed minus 12. So I can reverse FOIL this. So I got parentheses, parentheses. I got y cubed and y cubed. This minus here and the 12 tells me that they're going to be different, and then the plus 4 means that the larger value is going to be attached to the plus, and so it's going to have a 6 and 2, and that is factored out completely. Looking at C, I noticed that this looks a lot like sum of two cubes, where if I generalize it as A, here that would equal 5x to the third, and my B would equal 4y. So by using the formulas that I had in the beginning of the notes, I can substitute in these values to factor this out completely. So I can say this would equal 5x to the third plus 4y times the quantity 25x to the 6 minus 20x cubed y plus 16y squared. Okay. Last thing we have is being able to solve polynomial equations. So what we need to do is, first off, is we need to get our polynomial equal to 0, so we can solve for x that way. So first off, I'm going to add 56 to both sides, which is 64 x to the fourth minus 8x cubed minus 42x squared plus 56x equals 0. Now I look at that, and I can factor out a 2x here, so that leaves me with 3x cubed minus 4x squared minus 21x plus 28 equals 0. Now I'm thinking I can do grouping like I did in other things in this section. And so I'm going to say 2x here, and that leaves me with can factor out a 3x here. That leaves me with x squared minus 7. Minus, I can factor out a 4 here when there's x squared. There's a square here, I'm sorry. Minus 7 equals 0. Now I have 2x. I have a common factor of x squared minus 7. And I can also multiply this by 3x minus 4 equals 0. So now if I use the zero product property, I find out that my x equals 0. It can also equal 4 over 3 and plus or minus the square root of 7. Looking at b, I'm going to move these values to the left-hand side of the equal sign because I like my highest degree to have a positive coefficient. So I'm going to go 2x to the 4th minus 42x squared minus 200 equals 0. I could factor out a 2 out of here, so I got 2 divided by x to the 4th minus 21x squared minus 100 equals 0. I could FOIL this out, or reverse FOIL it out, I mean. So this would be x squared plus minus. This would be 4. This is 21. And, oh, I'm sorry, this would be 25. My bad. So I got 2, I got x squared plus 4. This can be rewritten as the sum, as the difference of two squares. So that'd be what, x plus 5 and x minus 5 equals 0. Now I can use the zero product property. So I know that my x will equal negative 5 and my x will equal 5. But now if I look at x squared plus 4, if I were to say x squared plus 4 equals 0, subtract both sides by 4, so then I got x equals negative 4. If I try to take the square root of that, I can't, because I can't take the square root of a negative number and make it imaginary, so it's not a real number. So I can't make that into a solution. So my only solutions here would be negative 5 and 5. And that is solving polynomial equations and also factoring them out completely. Hope this helps. Until next time.